Good afternoon, everyone. Welcome, welcome. Wait for one more minute and before we get started. Glad you can join us. Okay. Well, hello everyone and welcome and thank you for joining us today. I am Nina Dallas Alice, a senior associate at MN Associates Inc. or MNA. MNA serves as the Research and Evaluation Technical Assistance Support Provider for the STEM Resource and Evaluation Center, also known as STEM Rec. We are so happy that you are here with us attending, and we're happy to be the host for this virtual event, which introduces Hedges G and how it can be used in evaluating or researching STEM grants. Next slide. To get us started, we'd like to know who is in the audience and see what you are curious about regarding today's topic. In the chat, we invite you to introduce yourself by sharing your name, institution, and project track if you have an STEM award, and perhaps one or two questions you have about Hedges G and statistical analysis for small sample sizes. If you have used Hedges G or any other statistical analysis for small sample sizes, please let us know in your chat. In the meantime, I'm just going to go ahead and move forward, but please continue to introduce yourself and post your questions or comments in the chat. And thank you for doing this, as all these questions and comments will help guide our discussion today. Next slide. So let me quickly go over a few housekeeping items to get us all better acquainted and better facilitation in this session. Throughout the webinar, we encourage you to write questions or comments in the chat. When we get to the Q&A portion and you wish to speak to ask a question, you may use the raise your hand button and we will call on you. If you are comfortable doing so, we also welcome you to turn on your camera. Today's slides are available for download as well. We'll post the slide deck URL and event page and other resources that we mentioned throughout this session in the chat. We'll also post the recording of today's webinar on the event page when it becomes available. So if you're just joining us or haven't done so already, please feel free to introduce yourself, your name, your institution. If you have a track number, any questions you might have, please do so in the chat. Now, I also want to call your attention to additional colleagues helping us today. We are happy to have a live transcriptioner providing closed captioning and making the information presented in this webinar as more widely accessible. We also have our AAA Ask colleagues to support us. So should you have any technical difficulties or questions, please contact Jamila Blake in the chat, or you can also send her an email at jblake@AAS.org. So thank you, Steve. Thank you, Jamila. And thank you, Tara, who's also helping us with some of the chat information being uploaded. Finally, we would really appreciate your feedback on today's session. Toward the end of the webinar, we'll provide a link to a short participant survey. This survey will also pop up when you exit out of Zoom. We thank you in advance for taking a minute to complete it. Next slide. Before we dive in, it's important for me to share a few disclaimers with you. This material is based upon work supported by the National Science Foundation under the grant number 222-4093. Any opinions, findings, interpretations, conclusions, or recommendations expressed in this material are those of its authors and do not represent the views of the AAAS Board of Directors, the Council of AAAS, AAAS members, or the National Science Foundation. Additionally, AAAS STEM Rec is promoting consultation with MNA, as they are the REC partner. However, this does not constitute an endorsement of M&A as evaluators by the National Science Foundation. Next slide. For those of you new to AAA S STEM Rec, in October 2022, through a competitive proposal process, AAAS received NSF funding to manage the S STEM Resource and Evaluation Center, or REC for short. The REC's work focuses on promoting effective strategies and practices to increase the number of talented, low-income students who obtain degrees and careers in STEM. All of REC's activities work across multiple levels to increase the capacity of the entire S STEM portfolio, the campus S STEM programs, as well as the professional development of S STEM scholars. We welcome you to check out the REC website to learn more and join our mailing list. And we do post new materials frequently. For more information about AAAS S STEM Rec, please visit our About webpage. And we also encourage you to join the listserv to receive our monthly newsletter. All the links are going to be provided in the chat. Thank you, Tara. Next slide, please. While the REC is managed by AAAS in coordination with NSF, the full team is composed of several partner organizations. This slide shows all of them. My organization, M&A, provides research and evaluation technical assistance support to current and prospective S STEM awardees, and we're happy to facilitate this webinar. Next slide, please. Today's webinar will address generating knowledge when evaluating small sample sizes, typically with tracks 1 and 2 as STEM grants. We'll introduce Hedges G and explore ways to incorporate findings from its application into evaluation reports. Next slide, please. And here's a quick agenda. We will reserve the last 15 to 20 minutes for Q&A and also for wrapping up. Next slide, please. Today's session is part 1 of 2 webinars. We'll have some hands-on interactive experience working on Hedges G next week. So please join us for part 2 of the series on Wednesday, September 3rd at 3:30 p.m. Eastern. You can register for the webinar using the link posted in the chat. Next slide. Oh, right, perfect. So it's my pleasure to introduce my colleague, Daniel Bernal, to lead us through today's presentation. Daniel is a senior associate at M&A Associates, Inc., specializing in data analysis, evaluation design, and statistical methods tailored for education and workforce development programs. He holds a BA in mathematics from Carleton College, a master's in education in learning, design, and technology from St. Mary's University of Minnesota, and a certification in data analytics and visualization from the University of Minnesota, Twin Cities. Daniel's expertise spans quantitative and qualitative analysis, survey design, and data visualization, with a focus on making evaluation findings accessible and meaningful to stakeholders. He has worked with various STEM programs, guiding them to adopt rigorous yet practical approaches to evaluation, particularly when dealing with small sample sizes and limited data sets. So Daniel, thanks for coming, and the floor is yours.
Thank you, Nina. Wonderful to meet with everyone today. This is a topic that I think is very relevant, especially as I see in the chat introductions, all of the, thank you for sharing your sample sizes that you're anticipating. And this is going to hopefully be a broad introduction, and we'll get into specifics at the next session. So hopefully I'll see you there too. But to make sure that we have an understanding of what we're talking about today, I want to start by talking about effect size. So effect size is a statistic or calculation like average, mean, median, mode, and it's used to describe the relative size of an observed difference or relationship. So when we talk about, like a pre or post, or the difference between 2 cohorts in terms of a test that they take or a survey that they take, the size of that difference is going to be very important. And effect size is kind of our standardized way to be able to say how meaningful is that difference. So in this example that I'm sharing, let's say that you had a survey, one cohort scored 0.93 points higher on average in the post survey than in the pre survey, and it was a 5 point scale. So what? What does that difference tell you? Is that meaningful? With a 5 point scale, we can kind of have an intuition about that. It's almost a point on that scale. But what if your items are on a different scale? Or what if you're using something like grade averages or something that's a little maybe less intuitive? So that's why we want to be able to calculate an effect size. You may have heard one popular way to calculate this is Cohen's d. So Jacob Cohen was a psychologist, a researcher, statistician, who really, I would say, popularized effect size in a way where it was very meaningfully used. And so oftentimes when we hear effect size, it's synonymous with Cohen's d. Um, However, we're going to talk today about when that might not be as effective and what is an alternative. Why do we talk effect size? Why did Jacob Cohen come up with this? You may be familiar with statistically significant tests, like p-values, but those only tell us about a set of data. What is the likelihood that that data was due to random chance? In other words, was that 0.93 point gain just they were clicking randomly on the survey, or it just happened to roll out that way in this group of students in the cohort, or is there something more meaningful going on? Part of the problem with p-values is that it really relies on a strong sample size. So if you have a smaller sample size, especially, it can be really hard to produce a statistically significant result in that sense. This is one reason we might go to effect size, because you can use effect size regardless of your sample, with a caveat, right? Which we'll talk about why Cohen's d might not be the best choice. But beyond that, effect size really rounds out our interpretation by explaining how large or meaningful the difference is. I think a lot of folks think of statistical significance as like, aha, this is proof that we have stumbled on something meaningful. And it is meaningful, but again, statistical significance talks about what is the likelihood that this sample can kind of tell us about a trend that's going on in the larger population. Effect size, on the other hand, really talks specifically about the data you are observing, the difference in that effect, and comparing that based on how that data is structured. So, what kind of data can be described with effect size? Specifically, we're talking about STEM, but we'll kind of be broad since I know a lot of folks here are learning in general about the topic. But any quantitative data where you're having some kind of difference. So that could be comparing two groups or cohorts. It could be 2 points in time, such as a pre and a post survey. It could be, beginning of the semester, midpoint, end of semester. Um, you could even do a more complicated thing with pairwise comparisons if you have more than two groups that you're doing, or averaging effect size over several cohorts, which we'll talk a little bit about today. So to ground this a little bit, I wanted to think of some examples, especially that might be relevant to folks on the STEM track. So if you have mentor programs, this could be, what is the hours of mentorship that students in your cohort are receiving? Why might they be receiving differing hours? And what is the meaning behind that difference, right? Mentor rubric ratings, if mentors are evaluating their cohort. Academic performance after mentoring. So if your intervention is mentoring, how can we see what impact that might be having on student academic performance? Retention rates in your mentor program. Um, this is something that especially I think relates to sample size, because if you have high attrition, that can really mess with your sample. And what you had designed at the beginning, you're like, wait, does this still even work with the attrition that I'm experiencing? So I think those are all really strong examples and kind of different examples. And they all have to do with that quantitative difference. STEM identity is another thing that we use a lot of quantitative measures of. So self-perception inventories, um, performance specifically in STEM courses, persistence or the intention to pursue careers in STEM. How does that change after an intervention or over time in a program? These are all examples of things that you can describe with an effect size. If you see a difference between two cohorts, or if you see growth over time, that is something that you can describe using effect size. So let's specifically talk about Hedges G. So Hedges was another statistician researcher who worked on the same types of things with effect size and developed a special bias correction factor for smaller samples because Hedges noticed that there was a little bit of a difference when you have that small sample size, and using some advanced statistical formulas was able to introduce a bias correction factor that was more accurate than a lot of the other ones at the time. Um, and so what we would say is Hedges G, we call it G. G is the measure, similar to p-value. You would say G equals something. That is an effect size that's standardized to be able to compare data from cohorts using standard deviation. Hopefully, I'm not losing some of you folks here. Bear with me. This is like the most math you will see today. Um, and you might notice something if you've taken a stats course in the image on this slide of the bell curve. Hopefully, this is ringing a bell, no pun intended. But each of those little bars is a standard deviation. So when you have data that is distributed in that bell curve, in other words, you have a lot of data focused on the average score, and then you have a few outliers in the high and the low. That standard deviation is a standard difference, measurement of difference away from the average. And what we can use with using that standard deviation to calculate effect size is it doesn't matter what data you're talking about because standard deviation is always going to be this kind of unit that we can use to compare very different data sets. So, in other words, it's like making sure that no matter what kind of clothing you're wearing, if you hopefully get the size of clothing you're used to, it's going to fit you as well. So it's kind of that standard that we use in statistics to be able to compare different data sets. And it's important that when we're talking about Hedges G or Cohen's D, that your data is similar in variation. So we're not talking about one group that's really far skewed to the high scores, and the other one that's kind of average. This is most helpful for data that has very similar variation. If you're administering a survey pre and post, or if you're comparing data that is measured in the same way year to year, cohort over cohort, you're going to have very similar variability, most likely. That's something that we will look at in part two. How do you know if you have similar variability? So don't worry about that too much today. But Hedges G is literally just the calculation for Cohen's D multiplied by this bias correction factor that accounts for the size of the sample. So this is where that power comes from for small sample sizes. So when would we use Hedges G? This is kind of your little checklist to make sure that if you remember this presentation and you're like, oh, we can use Hedges G for this. This is the checklist you need to use to make sure that you're doing it in a way that actually tracks with how it's built. So it's got to be comparing data, that quantitative data. Especially we can use this if the cohort is less than 20 in size, although some would even say anything less than 50, use this one instead of Cohen's D. When you have a very large sample, Cohen's d and Hedges g are going to be pretty identical. So you're always safe using Hedges g. Uh, it works best when groups have similar variability. And so again, the data that you're comparing is similar in terms of the instrument you're using, and it has to be normally distributed. Think bell curve. Data that is not on a bell curve is like if you roll a die, right, or you flip a coin, what number you get, or if whether you get heads or tails, is going to be fair chance, right? You have just as good of a chance to roll a six as you do a one when you roll a die. If you're taking a test, that's not the case, right? If you have a sample of students taking a survey or a test, there's going to be an average. Most students are going to, be clustered in around that average. So that's what we mean with bell curve. And then when we talk about Hedges G, the units, this is going to come into effect on the next slide. Remember that it's based on standard deviation. So how far away are you from that average when we're talking about the difference in growth or the difference between two cohorts? So interpreting Hedges G in context, Cohen developed a set of benchmarks based on the studies that he was seeing, his peers' work in the field, and that was that if your G or your D, if you're using Cohen's D, is zero point 0.2, that's a small effect. If it's zero point 0.5, that's a medium effect. And if it's zero point 0.8 or larger, that's a large effect. Again, the unit on this is standard deviations. So when we say a zero point 0.5 effect size, you're saying you're half a standard deviation away from the average or from the beginning or the different groups are half a standard deviation away from each other. So those are kind of the benchmarks. If you get near a point two, like if you have a 0.3, for example, you can call that small to medium. This is all contextual. And this is where we need to talk about field-specific rules of thumb. John Hattie published a huge meta-analysis in the field of education, where he looked at tons of different research studies that had been happening over decades in education about what were the best interventions, what were the things that impacted student performance the most. And actually, 0.25 effect size was something that was meaningful and had a relatively big impact when it came to all of these different variables. Um, Medicine, Cohen and Ferguson worked to establish that a baseline of zero point 0.5 was more in that kind of meaningful range. Some social sciences might even say as low as 0.10 can matter. What you're looking for is consistency within that field. So everything is relative. That number really helps us compare different differences that we're talking about. So some examples here to ground us. Let's say you had a mentorship intervention and you calculated Hedges G and it was a zero point 0.5. You can say that was a medium effect when we looked at self-reported STEM confidence and the differences after that intervention. If you have a tutoring program and you got zero point 0.3, you could say that's a small but meaningful effect on academic performance that we observed in the data. What happens if you get a really, really small effect size? You can still report that as showing no meaningful benefit. So if you had an advising program survey, a small number is something you can still report because it still means something relative to other studies, other cohorts, other data. I think this is something especially that comes up when we talk about p-values and statistical significant. Sometimes we say, oh, it wasn't statistically significant, so too bad. That still means something, though. We still want to report that because it means in that case that your data either didn't have a large enough sample to be statistically significant, or there actually is no meaningful difference there when you're looking at that data set. Similarly, regardless of what number you get for your effect size, as long as your calculations are accurate, that says something about the data that you're observing. So it's important to put any number that you get when you're doing this kind of calculation into that context. When we talk about effect size and thinking about whether a difference in quantitative data is meaningful or not, we also need to think about the context, not just of the field, but of your study or your program. This is something that could be best used in a mixed method evaluation where you have qualitative data or you have descriptive statistics that you're using to talk about what kind of cohort you have or what kind of interventions you had, what kind of outcomes you had. It's not going to be the big proof that something is happening here, right? It's going to be part of that bigger story, one piece of the story that you're telling with your data. Um, and similarly, if you have several uh, effect sizes that you're seeing either on different instruments or across different cohorts, you might do what's called a meta-analysis, where you could average the effect size over those. So meta-analysis is a different way to combine data across studies or across cohorts. It's not the same thing as effect size, but rather effect size could be used to conduct that meta-analysis and look at the overarching trends. So to break that down a little bit, let's say you have a peer mentorship program, you have three cohorts that you're working with, and you calculated the effect size for some instrument that you're using to collect data. Your first cohort, you had Hedges G was 0.18, small difference, small effect size. Cohort 2 had a larger effect size, 0.35, almost twice the difference in terms of that meaningful impact. Cohort 3 had an even smaller one. So this might feel initially like kind of a meager collection of effect sizes, and how do we interpret that? Um, Certainly mixed methods, you would look at what were the experiences of those three cohorts, what were the things that those students were saying after this mentorship program, what were the mentors saying, right? That is going to be super, super important for telling the story. Also, you can use a meta-analysis of those cohorts to find an average effect size. Let's say you do that and it's 0.26. That's a small to medium effect size. And so you can use that to represent the overall strength or meaningful impact of this mentorship program, even though your cohorts have kind of very different effect sizes. We should note here too, and we'll talk about this next week when we get into the calculating Hedges G, but this is assuming that those cohorts all have similar variability. If you have one cohort that like doubled in size because you completely changed your recruitment strategy and the descriptive statistics are showing that the demographics are very different, you might want to calculate the variability and see if that's the best measure. But again, that meta-analysis is going to tell you something about the data you have if you're looking at effect size in that meta-analysis. There are other ways to do effect size too. So if you are going through this checklist and you're like, I don't know that this is normally distributed, or I don't think our cohorts are similar enough to really warrant a comparison here. There are others. I won't go into these today, but you do have some, you might recognize correlation. Correlation coefficients is an effect size statistic. It's used for relationships, not when we're looking at the difference between two groups or two cohorts. So just know that Cohen's D and Hedges G are not the be all end all. There's a whole ecosystem when it comes to statistics and effect size, and really making sure that we are having the right tool for the task at hand. And again, Hedges G is going to be most useful when you're looking at the difference between two groups. So I think the key concepts to remember are, again, that Hedges G is an effect size statistic related to Cohen's D, specifically useful when comparing small sample sizes and looking at, I would say, two groups or two cohorts or the difference between two things. That effect size tells you how big the difference is, not just what the difference is. And so it's not the same thing as looking at the average or looking at the statistical significance. It's the relative size of the difference that you're observing in your data. And just for some clarity, this is one type of statistic that you might use in a mixed methods or meta-analysis alongside other statistics. Just a little bit of a preview of next week. When we have our session on September 3rd, we are going to walk through an example of how to calculate Hedges G, which also means we'll walk through how to calculate Cohen's D because they're related. And for that specifically, we're going to be using Google Sheets. One, because it's free, and that's a tool that anyone can use. And if you can do it there, it's maybe easier to do it in other places. But I know a lot of folks use different tools when you are looking at statistics. So we will also be sharing some resources for how can you look up how to do that in R or in Python or in other programs, just to make sure that when you walk away from next week's session, you will have been able to do a calculation of Hedges G one way, but also uh, if you have a preference for the platform or you're using a specific platform, we'll give you some hints on how to get started with that. Um, it's a relatively easy calculation, but sometimes that's hard because um, it just comes out so easily, and then you're like, okay, is this accurate? Did I do the math correctly? So we will give you all the tools that you need. We'll do a walkthrough together, and there will hopefully be very low anxiety if you're someone who has math anxiety. I was a math educator before I became a data person and researcher, and so I I know that people have anxiety around math. Trust me, it'll be worth it. We'll walk through it together, and hopefully we'll feel really good about Hedges G at the very least next week. There are some references and resources if you want to read more or find more about, especially some of those like foundational works where those benchmarks were really kind of first introduced, or some of the other ways that you can measure effect size. Meta-analysis is another thing that if you're interested or curious in that, especially in education, that visible learning by John Hattie, transformational in terms of the field and as an educator, just my own practice and understanding of when I see statistics, what do those mean? Um, but also some of these are really important if you are thinking of doing your own meta-analysis or using effect size with a set of data. They can help you understand better when is it appropriate, how might I go about doing this, how might I go about reporting on this. So you want to be able to use this confidently. So we want to make sure that you have some resources to be able to set yourself up for that. I went through that quickly, but I know that there were a lot of questions already in the chat. And so hopefully we'll have some time here to answer any questions that you have, unless they're ones that we want to get to next week when we're actually going through the calculations.
So thank you, Daniel. We now come to the Q&A portion of the webinar. And so just to buy us some time, I'm going to go ahead and start with one question. So Daniel, from your experiencing using Hedges G or another small sample size statistic, what did you find surprising as a result of applying, this approach? And like, based upon the data sets you've worked on.
Yeah, this is a good question, especially because the unit of Hedges G is standard deviations. That's not as intuitive necessarily. So when I was first using it and confident about my calculations even, I remember, one effect size was like 1.3. And I was like, that's way above the benchmark of zero point 0.8 for a large effect. What does that mean? Is this a super large effect? And so I think the getting used to how to interpret the number, I think is a really important part of being comfortable with talking about effect size. Especially when you're looking at foundational works like John Hattie, where it's like a point 0.4 was like, whoa, in education. So making sure that you're kind of understanding the relative size of all of these things. They're mostly quite small, especially if you have something that is a smaller sample size. But because the smaller sample size might be, you might have some really high flyers in that group, and those
Mm.
might kind of skew the data. Your effect size might show up as very big. So remember too that effect size talks about just that data set that you're looking at. It's not looking at extending that interpretation to a larger population.
Mm. Well, actually, that's a really great kind of intro to one of the questions that was posted. And the question is, so how skewed might your distribution need to be before you'd recommend, say, glasses method? So, because, you talk about potentially if you've got such a large, effect size, like that may also indicate you've got some outliers that are skewing things. So how can, again, going back to check the list of do you use Hedges G or not, based upon what you perceive as a distribution of your data set.
For sure. That's a great question that we can talk more about next week. But in general, I would say it's important to calculate the variability when you're doing these kind of statistics so you can see if the variability is very different. And we also have to keep in mind variability is different from being normally distributed. So the bell curve is the normal distribution. Variability just talks about the skewedness. So you can have a skewed bell curve, um, but you definitely want to make sure that you're looking at the variability as part of this calculation, not only to do the calculation, but also to say, wait a minute, is how reliable is this calculation going to be? So we'll get into that next week for sure.
And then speaking of next week, you mentioned, some of the platforms to do these calculations. Someone asked, could you also share information about if we use SPSS?
Yeah, we won't use that next week, but that will be included in the resources that we provide folks. So you could do that on your own afterwards. Just because there's no way that we can possibly do all of the platforms in our amount of time. But also having that foundational understanding of doing it in Excel with a small data set, I think will get you more comfortable using some of those other platforms where you'll kind of be able to say, oh, okay, so when we did this in Excel or Google Sheets, it's that's what we're putting into this formula or this code in the platform that I'm using.
Thanks. We have a question from Amy, and she asks, how does this compare for using students' t-tests?
Yeah, so great question. Back when I was introducing this, we talked about the difference between p-value, which is a statistical significance test. So that would be your student's t-test, is a statistical significance test. That's what we're doing to try to understand whether, we're comparing two data sets and we're saying, are these different enough where we think that's not due to random chance? Or are we saying any difference we see in these two data sets is probably just luck of the draw, right? Um, so again, that's talking about do the data sets mirror each other or the larger population? Effect size is really talking about, okay, there is a difference between these two data sets. What is the size of that difference? So it's a different question that you're asking and answering with Hedges G or Cohen's D compared to using the student's t-test.
Thanks. Another question we have you ever been in a situation where you measure multiple effect sizes for different metrics and then compare it for multiple cohorts or years? Does it make sense to have multiple effect sizes over multiple cohorts or years? And is this a situation when it makes sense to do a meta-analysis when one cohort or year to be able to make better comparisons?
Yeah,
So it's a
that's a great question too. Because a meta-analysis, you're really looking at what does this entire collection of data say, right? What can we say about it? Versus if you were to report on the effect size of each of your cohorts just separately, that I think would be really helpful for comparing those cohorts, especially if you're trying to associate those differences with changes you're making in your program or some of the descriptive statistics. So effect size doesn't tell you why those differences exist, but they can tell you the relative size of those differences. And that's, I think, the power when we're specifically talking effect size. So does it make sense? It depends on what your story is that you're trying to tell or what your parameters are for your study, um, which one you would do. Yeah.
okay. And kind of related to that, someone asked, um, so what is too small for this type of analysis? Because you showed like, as small as 20, but then what's like too small? Because we saw some people were sharing their
Yeah.
n sizes, and some
Very
there's a
small.
wide range.
Yeah. Um, if one person takes a test, they have an average score. It's the test result they got, right? So I think when we talk about what is too small, it's still going to always be relative. Often those small samples um, are labeled problematic because you can't do the p-value, you can't do the statistical significance. And for a long time, that was the gold standard of statistics. And so really that foundational work in effect size started to shift the conversation a little bit away from that. And there's some really cool things you can check out if this is really your jam, into non-Bayesian statistics, where we're really talking about modeling using your data set. So there's a spectrum of statistics. Um, when we talk about effect size and Hedges D specifically, remember that this is describing the data that you have, regardless of your sample size. So there's nothing that is too small for you to use. It's more about interpreting that. If you have a sample size of 4, you can talk about the effect size to what end, right? What are you going to do with that information? If it's simply reporting that, hey, we had a lot of attrition, so here's our sample size. We ran effect size to see what the growth was, how meaningful of a difference the growth was. That's kind of the limitations that you have with that statistic. You can't really say that a whole program is going to be one way or another based on a sample of 4. Um, so I think it's a and it's not just a way to say, oops, small sample size, better use effect size statistics. This really should be part of telling the bigger story around your data. And your data is your data. You can't control attrition to a certain extent, right? You can use effect size as part of the things that you use to tell the story about that data. I think there was a question too that's kind of similar, that was either just put in at the beginning or I think was shared in registration, that was talking about what happens if you add
Yes. So
numbers
how
to
to
your
deal with the issue
sample.
of adding a few more cases or participants could possibly change results. Yeah.
Yeah, exactly. And this is why it's always important to report your sample size. And let's say you've already reported that smaller sample. and you're adding more, you got to say that. You have to put the caveat that, by the way, we added these samples. This is why. And I think it's important to really make a case for why you are going to add samples. If it's like, um, you know, uh, some members of your cohort took the survey a couple days later, that's fine. Include those in, right? If you were eager and ran the test based on the, first day of responses, and then, you got some additional ones afterwards, that's fine. Just use the full sample. If those students took the survey months afterwards because they randomly clicked the link in their email that you sent them a long time ago, that's different. You can't account for the experiences they've had in those 2 months that may impact that. So it's really up to you to decide, are we going to include these and why or why not? The math is going to play out regardless of the decision you make. So it's important that whatever decision you make, you're documenting it, you're reporting it alongside the statistics that you're calculating, because that's that standard of kind of research and repeatability that we aim for when we're doing this type of study.
Yeah, good question. Good thoughts there. So I think kind of related to that would be is, and I think this happens a lot with STEM. So you have a cohort, say you have a cohort of 10, right? But for some reason, whether because the students lost their eligibility because maybe they went through academic probation or they drop out because something in their life happened, right? They had to skip. And so you say you lost like five in that first cohort. But then so you still have money to the disperse for the scholarships, so you get five more. So now it comes to defining and then you're implementing the instruments again for collecting data from your, initially. So how do you then call, is this cohort 1A, cohort 1B? And then being able to then compare and contrast and see the effect because could be slightly different because of the way the group is ending up.
For sure, yeah. When you're thinking about a sample size, you have to think about the word sample, right? This is a sample population. We there are many, many students that could be part of your program that aren't for whatever reason, or your cohort changes. It really is one of those situations where you have to look at what you're reporting and how you're reporting. I feel like I sound like a broken record here, but often it comes back to that. So if you know all of your cohort took the pre-survey, right, and you want to report out on that pre-survey, but only half of them completed the post-survey, um, if you're using both of those samples, you have to say that and put a huge caveat there. What I would say is more, what I see as more kind of rigorous or more conservative in terms of reporting out would be to say, let's use a matched pre and post. Let's only include the folks who took both because we can account for the variable of attrition or retention in that situation. Um, but it gets murky, right? That you aren't just doing a pre-post. You have so much data that you're collecting as part of your research and your programs. So it really is going to depend on your specific context and making sure that you're responsible to uh, where these numbers are coming from, how this, how, what drove your decisions to use this statistic versus this one, what drove your decisions to include or not include certain data points that you may have collected, right? Um, I think oftentimes researchers and statisticians feel obligated to report everything, um, which is not quite true, right? It's like we do have choices over what to include, but you have to be able to say why you're making that choice. And this is what we refer to as cleaning a data set. If you are just dumping all of your data into a program like SPSS and taking whatever number it gives you, that's not quite right. You really want to make sure that you're defining your data sets well, that the data is exactly what you're thinking to do it. And when you press run on that program to give you that statistic, you're confident that you're making all of those decisions you made to include or not include are are part of that intentionality around using this statistic or that statistic, right? Yeah, early graduations, transfer. I'm just seeing Amy's comment there. Um, there was a question about if you have multiple, if your program is several years long, but you're only funded for 3, how do you report if only, one or two cohorts even make it through graduation at the end of your program? These are all situations that are real, dealt with them several times. Um, and you have to be able to make those decisions on what to include, what caveats to include. It doesn't mean your research falls apart. It does mean you have to be careful when you're reporting, and say exactly what you're reporting on.
Yeah. Yeah, I think and this is one of those questions that came up even before that was part of the registration is that um, folks are saying that it's even more challenging when you've got them small n size, and then you're saying then the best of the two cohorts they go on to matriculate to or graduate. So, for example, if you're working with community colleges, you've got your cohort, great, but then they move on to say 4-year university, and then trying to track them from then on out in another in not your institution, in somebody else's institution, right? And so yeah, that and then how do you handle that?
Yeah. Yeah.
Yeah.
They're great questions. If folks think of more, come next week, ask them in person, or via the Zoom, because we'll continue parts of this conversation and hopefully make it more grounded in an example together.
Yeah. So we have a few more minutes. Are there any questions or comments people want to share? Okay. Hey, Jennifer, go on ahead.
So this is making me wonder how useful our STEM is going to be if we can never, our cohorts are small. We can only afford like 9 students per cohort. How can we ever extrapolate to the wider population and say, okay, this was something useful, go beyond this was useful, or there was an effect for our students and apply it to the larger low income groups that are at our universities?
It's a great question. So I would say like one um, really useful tool about meta-analysis is it does take into account several sample sizes altogether. When you're doing that average, you're not just adding up all the effect sizes and dividing by the number of studies. You actually have to be able to have some of the data there to say how large was sample one, how large was sample two. And so you can. Right. The power of a sample size doesn't just come from that sample. It comes from repetition. Can we repeat this over time? This is why a cohort model makes sense in a lot of research situations. But also it's a starting point, right? Effect size in and of itself means something about that data. And if we want to further investigate some of those things, those are really good targets. If you see a strong effect size in a sample that's small, let's try it in another population. Let's try it with more students. Um, that's how I view it. Not everyone might view it that way, but I would say don't get too discouraged. The work you're doing is still important, and I think being able to report the work you're doing is you never know where that's going to land you or the field, right? Every research question started somewhere.
So thank you, Jennifer, for that question. And for those of you, we can move on to our kind of wrapping up here. So if you have additional questions, as we said, we have a part 2. And also, here's another opportunity to do so, and that is the STEM REC Evaluation Technical Assistance Request Form. So if you have more questions about this webinar, you want to consult with M&A or have an STEM project evaluation or research questions, or you just go ahead and fill this out, and we will get back to you. Okay. Next slide, please. We really like to not leave you empty-handed, as you can see. So we want to call your attention to the resources available in the REC website. We recently have added new evidence-based practices, or EBPs, yesterday, and they cover practices such as tutoring, faculty interactions outside of the classroom, field trips, social emotional learning, and even mental health services. So please feel free to check them out in the STEM REC resources page. Then we also have the ever popular guidebook for preparing research and evaluation. So I've seen some folks here who are contemplating, taking part in the next call for proposals. So please check this guidebook out, and it might really, really help you. I think, based upon our experiences, people have given us a thumbs up on that. And then, as you've heard, this is only part 1 of part 2 of, part 1 of 2 webinars that we're presenting. And so we have the next session on Wednesday, September 3rd at 3:30 p.m. The link's in the chat. Please register for that session, and we'll continue to respond to some of the questions you're having into that session as well. So we'll bank them and then respond to them. And maybe by working on the actual data set, it might make things a little bit easier to understand. Next slide, please. We love data. So we really ask that you contribute to that by providing us with your feedback on today's session. So please, 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 if you could, kindly complete this short participant survey. The link can be found on this slide. You see the QRL code. This will also pop up on your screen when you exit the Zoom app. So thanks again for taking a moment to complete this, as your insights really help us improve what we provide for you in terms of webinars, resources, and so on. We wouldn't be able to develop these without your feedback. Next slide, please. And so we really thank you for participating, helping us with all the questions and comments you've made. A really big thank you for Daniel for starting it off in this inquiry. And thank you for our partners, our colleagues at AAAS, Steve, our transcriptioner. Thanks to everyone here in the audience for these great questions and inquiries. We'd love to stay connected. So, please check out our website, the resources, the monthly newsletter, and interact with us definitely through our various social media platforms. And we'll leave all those links in the chat. So we'll linger for a little bit more, 3 more minutes. But thank you again, and we hope to see you next Wednesday when we'll get deeper into Hedges G with some sample data sets. Until then, have a wonderful rest of the week.